Welcome to this tutorial on industrial instrumentation. In this tutorial, we will talk about temperature measurement part 6 and limit ourselves to thermocouples. The topics that we'll discuss here are thermocouple and its principle, cold junction compensation, thermocouple types, and the advantages and limitations of thermocouple. The thermocouple is the second type of electrical type temperature measurement device that is used to measure very high temperature. They give considerable linear output up to a certain temperature value, and beyond that the scale tends to become nonlinear as shown in equation 1 below. The thermocouples are self-powered devices and do not require any external power supply. The thermocouple device comprises two junctions made up of dissimilar metals or alloys which are welded or riveted together and encased in a metal sheet, and it is the junction where the temperature is measured. When the measuring junctions are heated, a voltage is produced that is greater than the reference junction, which is also called the cold junction. The changes in the junction temperature gives rise to junction potential difference in terms of voltage, which is measured and the temperature is determined. The voltage generated is interpreted using the thermocouple reference table to calculate the exact temperature values. The thermocouples do not actually measure absolute temperature, and the temperature differences between the junctions, that the hot junction and the cold junction, is measured. The resultant voltage is given by the Seebeck effect equation as shown in equation 2 below. As we see here, the voltage generated is proportional to the temperature difference. It was T.J. Seebeck who observed first that the conductors generate voltage when exposed to temperature gradients. This phenomenon of the conductors is named as Seebeck effect. As the energetic electrons at the hot junction diffuse towards the cold junction, a higher static potential is built at the hot junction compared to the cold junction. In the classical configuration, the cold junction or the reference junction is normally maintained at 0 degrees Celsius by submerging it in ice bath, while it is only the hot junction that is exposed to heating. The thermocouples work on the thermoelectric effects, that is Seebeck effect, Peltier effect and Thomson effect, and the laws of thermoelectricity, that is law of homogeneous materials, law of intermediate material, and law of successive or intermediate temperature, which are already discussed. There are several types of thermocouples based on the junction, metal, or alloy composition, and each of these types have their own unique features in terms of range, durability, response speed, vibration resistance, chemical resistance, application, and compatibility. The thermocouples can be connected in either series configuration or parallel configuration to form thermopiles. In industries, the process environment is not only hot but also pressurized, and there can be corrosive chemicals and substances which are radioactive in nature. Such conditions are capable of damaging the regular temperature sensors. Therefore, the thermocouple are modified into thermowells, which are basically hollow metal tubes having one end open and the other end sealed. The thermocouple sensor is inserted inside this hollow tube, which is then introduced in the process environment. The main advantage of the thermowell is that it can handle pressurized, chemical, corrosive, and radioactive environment, but at the cost of slow measurement response. The thermocouple operation does require a stable voltage reference and some form of ice point or cold junction point. Since the thermocouples measure temperature differentially, the cold junction temperature must be a known temperature to correctly determine the differential temperature. But due to the operational limitations and errors, the cold junction temperature rises above the ice point. Therefore, the output voltage needs to be compensated to account for the voltage created at the non-zero cold junction. The process of this voltage compensation is called cold junction compensation. Another set of temperature sensor is used to measure the temperature at the cold junction, and the corresponding junction voltage is looked up from the thermocouple reference table. This compensation then allows the electronic component in the device circuit to use the established thermoelectric voltage tables or polynomials to determine the temperature at the hot end. It is because of the cold junction compensation that now thermocouples have come out from the laboratories and are largely used in the industry setup. The thermocouple types are based on the metal alloy combinations for the two junctions. These metal alloy combinations are chosen to match different requirements like temperature range, sensitivity, inertness, and magnetic effects. There are mainly 9 types of thermocouples based on the material compositions, namely J, K, T, E, R, B, S, M, and N. Other than these 9 types, there are also the C, D, G, P, and W types. The temperature ranges of each of these thermocouples vary because of their composition as well as their accuracies. We see here that the best accuracy is provided by the R and the S type thermocouples, both of which are made up of platinum and rhodium. The B type thermocouple has the highest temperature measurement range, while the K, T, E, and N type thermocouples can measure very low temperatures as low as minus 270 degrees Celsius. Based on the percentage composition, the platinum rhodium thermocouples are of 3 types, which are R, B, and S types. Iron, copper, and nickel chromium couple with constantan, that is an alloy of copper and nickel, form the J, T, and E type thermocouples respectively. J, K, T, and E type thermocouples are called base metal thermocouples, which are the most common type of thermocouples. S, R, and B type thermocouples are called the noble metal thermocouples, which are used in high temperature measurement application. The advantages of the thermocouple are that they are capable to measure temperature directly up to 1800 degrees Celsius. Very few special thermometers are there that can measure up to 2600 degrees Celsius. The devices can be brought in contact with the system under measurement. The thermocouples have very high resolution and reliability of measurement. The thermocouples are rugged and robust in build. The limitations of the thermocouple are, however, after a certain temperature value, the scale tends to become nonlinear. The thermocouple operation, from construction to calibration to measurement, is somewhat complex. It requires 2 sets of measurement for full comprehension. The device requires calibration sometimes even in the middle of the usage. A thermopile is an electronic device that converts thermal energy into electrical energy. It is made up of several thermocouples connected in series or sometimes in parallel connection. The thermopile does not respond to absolute temperature but generates an output voltage that is proportional to the local temperature difference or temperature gradient. The thermopile output is in voltage and ranges from tens of millivolts to tens of volts. The output voltage of a thermopile is n times the response of a single thermocouple if n thermocouples are connected in series configuration. The resultant thermopile voltage output is given as shown in the equation below, that is E equal to E1 plus E2 plus dot 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 to En. Readers can refer to the following links and references for more detailed study. Thank you.